If you dropped an octopus from a coral reef into the Hadal Zone, it would look completely unrecognizable within a few generations. Its eyes would balloon to the size of golf balls. Its skin would turn ghostly pale or completely transparent. Its arms would stretch into impossibly long tendrils that seem to move with their own alien intelligence. The deep ocean does not just change octopuses. It warps them into something that barely resembles the creatures we see in aquariums. These are not the cute, color-changing animals that open jars and solve puzzles for YouTube videos. These are drifting phantoms with flesh like wet paper, and bodies designed for a world where light does not exist and pressure would crush a submarine. But here is what makes octopuses different from everything else down there. They are not just surviving the abyss, they are thriving in it. And they are doing it in ways that seem almost impossible for a creature with no skeleton, no shell, and a brain that is basically wrapped around its throat. So why does the deep ocean turn these intelligent, adaptable animals into something straight out of a fever dream? And how do octopuses manage to dominate an environment that kills almost everything else? To understand what is happening to these creatures, we first need to understand where they are going. The ocean is not just one big pool of water. It is layered like a nightmare cake, and each layer gets progressively worse for anything trying to live there. At the surface, you have your typical octopuses, the common octopus, the blue-ringed octopus, and the giant Pacific octopus. These are the celebrities of the cephalopod world. They live in the sunlit epipelagic zone, where there is plenty of light, plenty of food, and plenty of reason to look normal. But drop below 200 meters, and you enter the twilight zone. Suddenly, things start getting weird. Octopuses here begin developing larger eyes because every photon of light becomes precious. Their bodies start shifting, becoming more gelatinous, because there is less need for the muscular strength required to hunt in open water. Go deeper into the midnight zone, past 1,000 meters, and the transformation accelerates. By the time you hit the abyssal zone at 4,000 meters, you are looking at creatures that have abandoned almost everything that makes an octopus look like an octopus. The Dumbo octopus is probably the most famous example of what happens when you let evolution cook in complete darkness for millions of years. These animals have ear-like fins sticking out of their heads that they flap to move through the water. They do not jet around like normal octopuses. They literally fly through the abyss like underwater ghosts with too many arms. Their eyes are massive relative to their body size, designed to catch the faintest traces of bioluminescence from other creatures. Their skin is so thin, you can sometimes see internal organs through it, and their arms are connected by webbing that makes them look less like an octopus and more like a floating umbrella that somehow learned to hunt. We have recorded Dumbo octopuses at depths exceeding 7,000 meters. That is deeper than most submersibles can safely go. These animals are hanging out in pressures that would turn a human body into something resembling toothpaste, and they are just casually swimming around looking for dinner. But why do they look so different from their shallow water cousins? The answer is that every single part of a deep-sea octopus has been redesigned by evolution to solve problems that do not exist anywhere else on Earth. Take the pressure problem first. At 4,000 meters deep, you are dealing with pressure roughly 400 times greater than at the surface. For most animals, this would be an immediate death sentence. Bones would crack, lungs would collapse, air-filled cavities would be crushed flat. But octopuses do not have any of those problems because they do not have bones or lungs or air-filled anything. Their bodies are almost entirely soft tissue. And while that might sound like a weakness, it actually makes them nearly invulnerable to pressure. There is nothing rigid to break, nothing hollow to collapse. The water pressure just squeezes everything equally, and the octopus barely notices. This is why octopuses have colonized the deep ocean more successfully than almost any other complex animal. They were pre-adapted for extreme pressure by being squishy. Evolution looked at the blueprint for an octopus and said, yes, this will work just fine at depths that would kill a submarine. But surviving pressure is just the first challenge. The bigger problem is food. More specifically, the complete lack of it. In the sunlit zone, food is everywhere. Plankton blooms, fish schools, crabs hiding in rocks. A surface octopus can hunt actively because there is always something nearby to eat. In the deep ocean, food is so scarce that hunting like a normal predator would burn more calories than you could possibly consume. So deep-sea octopuses evolved a completely different strategy. Instead of hunting, they drift. Instead of chasing prey, they wait. Instead of being muscular and active, they became gelatinous and patient. Grimpoteuthis, a Dumbo octopus species, essentially floats just above the seafloor with its arms spread wide like a net. It does not chase anything. It just waits for something to blunder into those arms, then closes them like a trap and stuffs whatever it caught into its mouth. This is why deep-sea octopuses look so weird compared to their shallow water relatives. Every adaptation is designed to minimize energy expenditure while maximizing the chances of grabbing whatever rare food floats by. Big eyes to spot opportunities in near total darkness. Gelatinous bodies that require almost no energy to maintain. Long, webbed arms that can cover a larger area without expending effort. They are not hunting. They are fishing. And they have become terrifyingly good at it. But the strangest adaptation might be what has happened to their brains. Octopuses are famous for being intelligent. The common octopus has about 500 million neurons, roughly the same as a dog. They can solve puzzles, use tools, and recognize individual human faces. Scientists have documented them escaping from aquariums, opening child-proof containers, and even showing what might be play behavior. So what happens to all that intelligence when an octopus moves into the abyss? Here is the thing. We do not entirely know. Deep-sea octopuses are so hard to study that most of what we understand about them comes from brief glimpses captured by submersibles or the occasional specimen that gets pulled up in fishing nets. Those specimens are usually dead or dying because you cannot bring an animal adapted to 6,000 meters of depth up to the surface without causing serious problems. What we do know is that their brains have not gotten smaller. If anything, they seem to have become more specialized. Some species have developed neural structures we have never seen in shallow water octopuses. Others have expanded the parts of their brain associated with processing sensory information, probably to make better use of what little input they get in the darkness. One theory is that deep-sea octopuses have traded general intelligence for specialized survival skills. Instead of being smart at everything, they have become experts at the specific challenges of living in eternal night, detecting the faintest pressure, changes from nearby movement, sensing chemical traces in the water to find food or mates, processing tiny amounts of visual information to identify whether that faint glow in the distance is dinner or death. It is not that they are dumber. It is that they are smart in ways we do not have good tools to measure. But perhaps the most disturbing transformation happens to the deepest octopuses of all. Species like Vulcanoctopus hydrothermalis, which lives around hydrothermal vents at depths exceeding 2,500 meters, have evolved adaptations that seem almost impossible. These vents spew superheated water loaded with toxic chemicals. The temperature can exceed 400 degrees Celsius right at the vent opening, The water is acidic enough to dissolve metal. Hydrogen sulfide, poisonous to most life, saturates everything. Normal animals die instantly near hydrothermal vents, but Vulcan octopus has figured out how to live there anyway. These octopuses cluster around the vents, somehow tolerating temperatures and chemical concentrations that would kill their shallow water relatives in seconds. We do not fully understand how they do it. Their blood chemistry seems different. Their cell membranes appear more resistant to heat and acid. They may have symbiotic bacteria helping them process toxic compounds, similar to the giant tube worms that live at the same vents. What we do know is that these octopuses have found a way to survive in conditions that should be lethal. And they are not just surviving. They are reproducing, raising young, and maintaining populations in one of the most hostile environments on Earth. It is like finding humans living comfortably on the surface of Venus. It should not be possible, but there they are. The reproductive strategies of deep-sea octopuses are equally horrifying. In most octopus species, the female dies shortly after her eggs hatch. She guards them, keeps them clean, and slowly starves to death because she stops eating during the brooding period. It is tragic, but it usually only lasts a few months. Deep-sea octopuses have taken this to an extreme that redefines maternal dedication. In 2007, researchers at the Monterey Bay Aquarium Research Institute started observing a female Granelodon boreopacifica guarding her eggs on a rocky ledge 1,400 meters below the surface. They kept checking on her, and checking on her, and checking on her. She was still there 4.5 years later. For 53 months, this octopus clung to the same spot, protecting her developing eggs, never once eating. Her skin turned pale. Her body shrank as she literally consumed herself to stay alive. Researchers watched her slowly waste away while her eggs developed in the cold, where metabolism runs so slowly that embryonic development takes years instead of weeks. When the eggs finally hatched, the female was barely alive. She had been brooding for longer than most octopuses live in total. Her entire existence after laying those eggs was nothing but waiting and dying slowly so her offspring could survive. This is the longest brooding period ever recorded for any animal. It is probably not even the record. There are octopuses living deeper than 1,400 meters in even colder water, where development would take even longer. Somewhere in the Hadal Zone right now, there might be an octopus that has been guarding her eggs for a decade. We just have not found her yet. But here's what really gets me about deep-sea octopuses. Despite all these insane adaptations, despite the monstrous appearances and nightmare fuel biology, they are still recognizably octopuses. They still have 8 arms. They still have complex nervous systems distributed throughout their bodies. They still have that weird beak hidden in the center of their arms. The basic blueprint is the same. Evolution just took that blueprint and stretched it in directions we could barely imagine. The flapjack octopus looks like a pancake with tentacles. The glass octopus is so transparent you can see straight through its body. The telescope octopus has eyes mounted on long stalks that stick out from its head like periscopes. Each one is weird in its own unique way, but each one is still fundamentally an octopus underneath all the modifications. It is like looking at what happens when you take a single design and optimize it for 100 different alien environments. The deep ocean is so varied, with such different conditions at different depths and different locations, that octopuses have evolved into dozens of bizarre forms. But they have all started from the same basic template, and they are all successful. Octopuses live in every ocean, at every depth we have explored. They have colonized hydrothermal vents, polar seas, abyssal plains, and Hadal trenches. Wherever there is water and something to eat, there is probably an octopus that has figured out how to live there. We have explored less than 20% of the ocean floor. Most of what we know about deep-sea octopuses comes from lucky encounters with submersibles or random specimens pulled up in nets. For every bizarre species we have documented, there could be dozens more we have never seen. The vampire squid, despite its name, is actually more closely related to octopuses than to squids. It lives in the oxygen minimum zone, where there is so little oxygen that most animals suffocate. Its eyes are proportionally the largest of any animal on Earth relative to body size, and it has been virtually unchanged for 300 million years, predating dinosaurs by a comfortable margin. 300 million years. This ancient creature was perfecting life in the deep ocean before there were flowers on land, before there were mammals, before there was anything we would recognize as a modern ecosystem. And it is still down there, drifting through oxygen, depleted waters, covered in light-producing organs, looking like something Lovecraft would have dreamed up after eating questionable seafood. The deep ocean does not just turn octopuses into monsters. It reveals what octopuses were always capable of becoming. Given enough time and enough pressure, literally and figuratively, these animals can transform into almost anything. Transparent ghosts, flying umbrellas, gelatinous nets, heat-resistant vent dwellers, decade-long mothers. The surface octopuses we know and love are just one version of what this body plan can do. The deep-sea octopuses are showing us all the other versions, the ones that evolved in darkness, in cold, in pressure, in conditions so extreme that we can barely send cameras down to look at them. Every time we send a submersible to a depth we have not explored before, we find something new, a new species, a new adaptation, a new reason to wonder what else is down there that we have not seen yet. The deepest parts of the ocean are less explored than the surface of Mars. We have better maps of the moon than we do of our own seafloor. Hiding in all that unexplored darkness are octopuses that have been evolving in isolation for millions of years, becoming things we can barely imagine. What else is down there, drifting through the eternal night with too many arms and eyes adapted for seeing in nothing? What other monsters has the deep ocean created from the same basic octopus blueprint? The honest answer is we have no idea. And that might be the most terrifying thing of all. If you want to learn about the other creatures that the deep ocean has transformed into monsters, check out the video on screen. Thanks for watching.